Now let's move on to a different partition editor. The gdisk partition editor is a command line tool for managing partitions on disks using the GPT partitioning scheme. The GPT partitioning scheme is used by newer systems running UEFI firmware. Please note that while the fdisk command that we just looked at does support GPT-style disk, this support is still considered experimental. So gdisk is a partition editor of choice when dealing with disks which use a GPT partitioning scheme. If gdisk is executed on a disk device that has an MBR partition scheme, gdisk will attempt to convert it from MBR to GPT format. This conversion is not a trivial process to be taken lightly, since it can result in data loss if circumstances are not well understood. This is why if you run gdisk on an MBR style disk, you will see a warning message. We'll demonstrate this now by running gdisk on the MBR style disk that we have been working with. Notice how gdisk immediately identifies that /dev/vdb contains an MBR partitioning scheme. As such, it also presents a warning message letting us know that if we were to proceed, a conversion from MBR to GPT format would take place, and that this operation could potentially result in data loss. If you ever run gdisk accidentally on an MBR style disk, simply enter Q to quit. Now let's see how we can use the gdisk command to manage disks with GPT partitioning scheme. To do this, we'll first reset our server so that we can have gdisk start with a brand new disk. To create a new partition on a disk with GPT partitioning scheme, you must first be logged in as a root user. Execute the gdisk command and pass the disk device name as the argument. Enter N to request a new partition. Specify a number for the new partition. This number is used to identify the new partition for future partitioning operations. We'll press Enter here to accept the default value of 1. gdisk needs to know where on the disk the new partition should be starting at. This is specified by sector number. You'll notice that gdisk displays a range of acceptable sector numbers for entry. The second input type that is accepted here indicates the partition starting sector by its position relative to the first or last sector of the first contiguous block of free sectors on the disk. A plus sign indicates a position after the first of the free contiguous sectors, while a minus sign indicates a position before the last of the first set of free contiguous sectors. When using this format, input is specified in units of kilobytes, megabytes, gigabytes, terabytes, or petabytes. We'll simply press Enter here to accept the default value of the first available sector number. We also need to specify where on the disk the new partition should end at. gdisk once again accepts two forms of input here as well. You can specify the absolute sector number that you want this partition to end at by entering a number, or you can specify the partition's ending sector by its position relative to the first or last sector of the contiguous block of free sectors on the disk. A plus sign indicates a position after the first of the free contiguous sectors, while a minus sign indicates a position before the last of the free contiguous sectors. When using this format, input once again is specified in units of kilobytes, megabytes, gigabytes, terabytes, or petabytes. We will use this input method to create a partition that is 512 megabytes in size. Specify the partition type for the new partition. To see a list of the partition types and their corresponding partition codes, you can use the capital L command. So for example, if we want the partition type to be Linux swap, we will enter 8200. Let's go ahead and add another partition of type Linux. Once again, we will use the command N to create a new partition. We'll accept the default value of 2 for the partition number. We'll accept the default value for the first sector of the new partition. And once again, we will request a partition size of 512 megabytes. Since we're creating a partition of type Linux, which is the default, we can simply press enter here. At this point, all the partition table changes that we have made are held in memory. To finalize the partition creation, we need to issue the W command to write the changes to the disk partition table. Once the changes are saved, gdisk will automatically exit. Lastly, to inform the kernel of the changes to the partition table, we need to execute the part_probe command on the disk device. Now we'll look at how to use the gdisk command to remove partitions on a disk using the GPT partitioning scheme. Once again, we will execute gdisk and specify the disk device name as an argument to the command. Enter the P command to print out the partition table. The output will list the identification number of each partition. Note the number of the partition you would like to remove. For example, we will begin by removing the Linux swap partition, which is partition number 1. We'll initiate a partition deletion by entering the D command for delete. Since there are multiple partitions on the disk, we need to identify the number of the partition to be deleted. We will enter 1 to remove the Linux swap partition. If we enter P to print out the partition table, we can see that we've now removed partition number 1 and that partition number 2 remains. Let's practice again by removing partition number 2. Notice how this time, after entering the D command, gdisk does not prompt us for the partition number because there is only one partition remaining. There is no ambiguity about which partition to remove. Once again, all changes made so far in this interactive session only resides in memory, so we'll want to enter the W command to write the changes to disk. Once again, when the changes are saved, gdisk will exit. Now we'll run the part_probe command on the disk device to force the kernel to reread the partition table and become aware of the changes just made.